Okay, infinite geometric series, Zeno's paradox, or you can't get there from here. But yes, you can, which is the paradox part, right? You don't have to write that down, you know. But if you're not here, oh, there we go. Now. Well, I already started it. Maybe I'll record them. I mean, we can't leave Richard hanging. He wants to review lessons.
Yes. Thank you.
If I remember, if I forget, then you got to remind me. Oh, right, because this morning I forgot. But so, anyways, you can look up Zeno's paradox if you want to read more about it. Okay, but you know, basically, it leads to the sum of an infinite geometric series, right? Because what terms would I be adding up, right? Well, half plus, what's half of a half? What's half of a quarter? So a half plus a quarter plus an eighth plus a 16th plus 1 and so on. And what is that going to all add up to?
1 minus the denominator.
Okay, you realize you're being recorded, so.
Possibly the other way around.
That was good. All right, so we want to add these up. And what are our partial sums going to be? So let's take a look at this. So you know, we know we got a half plus a quarter plus an eighth plus dot dot dot, and this dot 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 doesn't have anything at the end, right? So this is an infinite. We've looked at these, right? We said this is a finite sequence or finite series. This is an infinite sequence, and now this is an infinite series, right? We didn't do infinite geometric or arithmetic, right? I mean, that wouldn't make any sense really, because it just doesn't make any sense. It's always just going to get bigger, right, or smaller, or so the answer would be infinitely large or infinitely small. It'd be the same as if, like, instead of doing this, what if we did 1 plus 2 plus 4 plus, what's the sum there? If you do an infinite number of terms, what's the sum? Yeah, infinite. It's infinite, right? So we actually have names for these types of series. This one is called divergent because it does not come to a value, and this one is called convergent because it does, right? And I'll define those for you a bit later, in addition to having defined them now. So okay, if we look at the partial, so S1 for this series, what's S1? A half. What's S2? Yeah, half plus a quarter, or 3/4. What's S3? 7/8. Half plus a quarter plus 8, 7/8. What's S4?
15/16.
And so on, right? And I think if we continued that, it's what's S5? 31/32. What's S6? 63/64. What are we getting closer to? 1. Yeah. So as we increase the partial sums, we're getting closer and closer to 1. Will we ever get there? Yeah. Well, Zeno would say no, but we know that you do. Yeah, because you'll hit the wall. Okay, so where are we going to go from here? Let's talk about, well, while we're here, let's talk about convergent series. Okay, and so the example we're going to use is, let's go with, so what's this going to add up to? Well, let's do some partial sums to get there. Okay, so what's S1? 8. What's S2? What's S3? What's S4? What's S5? What's S6? What's S7? If I keep going, what am I going to get close to? 16, right? So this series will converge. It will reach a value. So as the number of terms increases, so let's write this down. As the number of terms increases, the sequence of partial sums approaches a fixed value. Approaches a fixed value of 16, right? You guys said it before, right? Of 16. Therefore, the sum of the series is 16. Okay, remember, this is an infinite series, right? It's 16. I can't write this one. The series is said to be convergent. Okay, convergent.
Converges on a point.
Yeah, converges on a value. The series is said to be convergent. Convergent. Okay? Which means it's a series with an infinite number of terms which approaches a fixed value. Okay? Convergent. As opposed to, what's the opposite of convergent? Divergent. Okay, so I'll give you a moment to write that down. Oh, let's just do the basic good old 1 plus 2 plus 4 plus 8 plus... Okay? Now, it's got to just be 3 dots, right? It needs to be an infinite series, so it can't be plus dot 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 plus 4096, right? Because then you can find the sum. That's one where we say, okay, how many terms are there? Right? You identify the number of terms. And, you know, what's the sum of this series? Okay, so you got to say, oh, it's not infinite, so I don't want to use the formula, which I don't yet know, for the sum of an infinite series, but which we will soon find out. Okay, so you're going to get a bunch of formulas, right? Arithmetic, t sub n is t1 plus a plus n minus. Sorry, I said a, and we don't use a anymore. We always used to use a as the first term of a series, right? But so I slipped. So it'd be t sub n is t1 plus n minus 1 times d. And then you get the two s sub n's, right? N over 2 t1 plus tn, or n over 2 2t1 plus whatever. Okay? And then you've got your geometric, right? So t sub n is t1 times r to the n minus 1. And you've got your two series. Sequence series, say the right word. You've got your two formulas for series. Right, and now we're going to add a third formula, which will be, not yet, we're going to define divergent first. Okay, so what's S1? What's S2? What's S3? What's S4? What's S5? 31. As I keep going, what's going to happen? It's going to get bigger and bigger and bigger and bigger, so we call that divergent, right? It will not approach a fixed value. It's just always going to be larger. Okay, so as the number of terms increases, the sum of the series continues to grow. As the number of terms increases. Why isn't today Friday? It feels like Friday. Doesn't it feel like Friday? Because maybe, I don't know, maybe because it was like Halloween yesterday or something. I don't know, it feels like Friday to me. And it's not, and that's depressing then, right? The sum of the series continues to grow. The sequence, as the number of terms increases, the sum. The number of terms increases, the sum of the series, the sum of the series continues to grow. the sequence of partial sums, the sequence of partial sums does not approach a fixed value. Okay, does not approach a fixed value. Therefore, the sum of this series cannot be calculated, and the series is said to be a divergent series. So therefore, the sum of this series cannot be calculated, this series is said to be a divergent series. Okay, good. I'll pause that while you write it. Okay, so the sum of a S sub n is T1 times 1 minus r to the n over 1 minus r, right? That's the sum of a geometric series? Yeah, got that one. Oh. Got those reversed, I guess, eh? Okay, you could do that, right? So this is just an alternate form of that.
You can put a minus in front of the T1.
Yeah, if you think of a minus in front of each, right, then we'll just change the signs of this. Oh, okay, you can use either one.
No, you can't.
Okay.
Let's see a minus sign on
Well, so here's the reason why I wrote it that way, as opposed to this way. Although, it really wouldn't matter, but you haven't seen that way. Well, okay, we'll do both ways. Just so you can be like, whoa, different formula. See, that's the one that I learned, I think, was this, and now we're using that one. It's sort of, they actually, we're not going to give you both, I don't believe, so. Anyways, check and see what they give you in 30. I don't even know if they give you that formula in 30. You know, it's not a 30 level topic anymore. Anyways. Oh, right. So okay, if you think about the series, a half plus a quarter plus an eighth plus a so on, right? Then you think about, in that series, r is equal to 1/2, right? So as we get out to really, really big values of n, right, T1000, then all of a sudden we're looking at 1/2 to the 1,000. How big is a half to the power of 1,000? You could say, like, not very. Right? Because we got half, a quarter, an eighth, a 16th, and we're like 1 over 16,384, 1 over 32,768. Soon we're 1 over like 2 to the power of a billion. 2 to the power of a billion is probably a fairly large number. 1 over that is pretty darn close to what? 0. So as we get really, really large, then this term simply goes away. Right? So if I'm summing up a billion terms, then this is pretty much 0. Which means that this becomes T1 over 1 minus r. Or, if we're over here, I guess, this becomes really, really large and goes to 0, which becomes negative T1 over r minus 1, but that's not really a good way to write it, so we'll just flip the signs around and do this. And become T1 over 1 minus r. Okay? So they're identical formulas, right? They're just two different forms. This one's kind of handy when r is greater than 1, right? Because then you know. This one's kind of handy if r is less than 1, because it gives you a nice positive value. If you're using calculators most of the time, it really doesn't matter, right? As long as you're careful and anything that's fractions put in brackets, life is good, right? Won't matter. Values work out. Okay, and I'm going to assume while you're doing your homework, right, or following along examples, you're following along to make sure that, yeah, okay, I'm doing this stuff right. You know, I'm entering it correctly into my calculator. Okay, so here's our formula for the sum of an infinite geometric series, right? It's just T1 over 1 minus R. See, here's the thing that makes it infinite, right? It's that the R value has to be between -1 and +1, right? I'm sure you've already figured this out. You said, hey, if the R value is like 2, then we get a series that goes like 2, 4, 8, 16, 32. That's going to be divergent, right? Or sorry, yeah. Sequences, series, convergent, divergent. You're going to keep those separate, right? Okay, so that's going to be divergent, right? It's never going to reach a value. If R is 3, then we get things like, 1, 3, 9, 27. You just get bigger and bigger and bigger. So to be convergent, our R value has to be less than 1, right? Or between -1 and 1. It's got to be a fraction. So you get a half, a quarter, an eighth, a 16th. So we get ever smaller, smaller, smaller bits, right? That's what makes this term go away, right? This term won't go away if R is 3. It'll just get really, really big, okay? So our R values need to be between -1 and +1. Okay, have we done absolute value? No? Okay. See, I never know, right? Cheating with classes. The 20-1s, you're doing a lot of the 20 stuff now. Keep your notes, okay? Because you're going to need them, because next semester, at the end of next semester, you're writing the 20-1 test. Sequences and series is on the 20-1 curriculum.
No.
Okay? All that rational stuff that you did, the adding and subtracting rationals, that's 20-1 curriculum, right? So you're going to be tested on it in January, but you will also be tested on it again in June when you write the 20-1 final. Okay? And we'll let you know at that point what's what, right? We'll say, okay, but don't throw out any of your notes or stuff like that, right? And just, be willing to stay up on it. Okay, so we have the formula for the sum, right? So what do we got? So T1 is the first term. And R is the common ratio. And S sub n is the sum of an infinite number of terms. Infinite. Okay, let's do it. Okay, what was the one we did? 8 plus 4 plus 2 plus... Okay, what's T1? 8. What's R? 1/2. Okay, that's all we need. That's all that's in the formula, right? It's T1 and R. Now what's S sub n? Don't know. So S sub n is T1 over 1 minus R, which is 8 over 1 minus 1/2, which is 8 over 1/2, which is 16. Right? So we don't have to do the partial sums now, right? We got the formula. And it says it's going to add up to 16. Okay, do another one. So here's another type of question I could ask, right? So here's a couple of geometric series. If it's convergent or divergent, identify convergent or divergent. If it's, what's the word? Convergent, then determine the sum, right?
Well, now we have a bigger chart too, possible.
And if it's divergent, then don't, because there isn't one. Okay? So again, I mean, there are questions that depend upon you getting the first part right to get the second part right, but I mean, you can always try summing this, and if you don't get, because if you go 1 minus R, and R is 2, and you got 1 minus 2 is -1, and you're going to think, no, I don't think so. Right? And if it's 3, then all of a sudden you're dividing by 2, and the series isn't likely, you're dividing by -2. And first of all, well, nothing was negative, and now all of a sudden the sum is -2? I don't think so. It's part of the problem-solving process, right? What's the last part of the problem-solving process? Step 4. Look back. Yeah. Look, does this make sense? Hey, I've got like 8 plus 4 plus 2, and I stuck a 2 in for R, and it's -8 is what it adds up to. Yeah, I don't think so. Not when I got 8 plus 4 plus 2. But let's try one that has some negatives in there.
Negative R.
I suppose actually I should write minus here, right? Not plus. Minus dot dot dot. Okay, convergent or divergent? Convergent. Okay, what's T1?
1.
What's R?
Negative 1 over 3. That's something.
What's T1? 1. Hmm? What's 1 over 4 over 3? 3 over 4. Okay? Yes? Alright, we can divide fractions, right? Divide by fraction. When you divide by fraction, you multiply by the reciprocal, right? So it becomes 1 times 3 over 4, or 3 over 4. So this will add up to 3/4, right? It will approach 3/4. So it's going to start off as 1, then it's going to go to 2/3, then it's going to go to, so what this is going to do is instead of, so when we're thinking like a half plus a quarter plus an eighth, is you're going to always climb 2, right? So if you graph the partial, it look like this, right? It's just going to get closer and closer to 1. This one's going to kind of go 1, 2/3. Above 3/4, below 3/4, above 3/4, below 3/4, above, below, above, below.
It's like
above,
heartbeat
below,
meter.
below. But eventually approaching, right? Because we're adding and we're subtracting, right? And the other one we're just adding, so it's just going to keep getting bigger, 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 but reaches a limit, right, which is 1. But in this one, we start off as 1. Then you go to 2/3. Then you go to, what's 2/3? It's 4/9 plus, so you get, then you go to 5/9, right? Then you go to whatever. Okay. And so on. But still, it, -2 plus 4 minus 8 plus dot dot dot. What do we need to say about this? List the info. What's T1? What's R? What can you say about the series? Divergent. Since what are we going to say? Since R is less than -1. How about since R is less than -1? Okay, it's divergent. Okay, what's next? Me? You know what? I think we're good. We're good.